Alrighty. Okay, functions and inverses we're going to be talking about today. Okay, and again, this is kind of laying the groundwork for some of the main ideas that we're going to be covering in this class overall. Okay, so obviously functions, we already kind of have an idea of what a function is, but then furthermore, inverses, those are, you know, you can kind of think of an inverse as another relationship, or a relationship that kind of undoes a function, right? It kind of cancels it out, right? We already have this idea about inverses. You can maybe think about like in algebra 1, right? You have like inverse operations. When you solve an equation, right? If you saw addition, what would you use to cancel out addition in an equation? Subtraction, right? Okay, those are inverse operations that cancel each other out, right? If you saw multiplication, what would you use to cancel out multiplication? Division, right? Again, those are inverse operations that cancel each other out. So functions and inverses have that same, a function and its inverse relationship has that same kind of relationship where a function can be kind of canceled out or eliminated by its inverse, okay? And we'll talk more about that as we go. So a classic example that we're going to see in our class is we'll learn about like quadratics or parabolas, you know, x squared. And then a little bit later down the line, we'll learn about the inverse of a parabola or quadratic, which is the square root of x, right? To cancel out a square, you use a square root. And then we'll talk about cubics, you know, x to the third, and then cube roots, the cube root of x, you know. So we'll talk about those things later. But that's the kind of groundwork we're laying here. Okay? So before we talk about functions, though, I want to mention the word relation. Okay? So in math, okay, the relation is a more like general vocabulary term here. Okay? And it basically is any pairing of an element of one set to an element in another set. Okay? So a relation is like the most basic, generic kind of like way to take one thing and relate it to another, right? We just say there's a relation there. Okay. Typically, the element of the first set, we're typically talking about like a domain. You can think about it in terms of the domain here. And then comparing it to the other set, and that would be maybe from the range. Okay. But it doesn't even have to be that specific, right? It's very generic. Okay. But then more specifically, so a special type of relation is a function. If you remember, right, maybe in the past, there were times when you had to determine, is this graph a function, or is this, you know, relationship, is that a function, right? So things don't have to be functions. We kind of throw that word function around a lot. We kind of like forget what it means, that it actually has a meaning and it's special. It's not just, you know, something that happens all the time. So a function is a relation, okay, where every input is paired with one output. Okay, and again, for input, you can think, well, what variable do we normally use for the input for our function? what variable is normally like the input we plug into the function? What variable is that? We plug in for x, right? Yeah. Okay. And for the output, what's the number we normally get out? What's the variable, the value we're getting out of the function? Yeah. Y, right? Yeah, the y. Okay, so another way to read this is a relation where every x is paired with one y. Okay, a relation where every x is paired with one y. Okay. So let's just take a look at some examples here. Is it a function? Okay, that's what we'll ask ourselves here first. So I made a little table there for us. So again, remember, a function is a relation where every x is paired with one y. Okay, is that so here? Is every x value paired with one y value? Yeah, negative 4 is paired with negative 2. 0 is paired with negative 3. 1 is paired with 2. 4 is paired with 1. Okay? So, yep, it's a function. Okay. All right, let's try another one here. I'll make another table. How about... another table here. Maybe I should do like example, something like that. To differentiate these here. All right, what about this table? Is this relationship, right? We're relating things, right? An x with a y, an x with a y, an x with a y, an x with a y. Is this relation, though, is it a function? Is every input paired with one output? Is every x paired with only one y value?
No.
No. Where does it fail?
Negative 4.
Yeah, negative 4, right. Okay, negative 4 is paired with negative 2, but negative 4 is also paired with positive 2. Okay, that's a problem, not a function. Okay, let me do one more here. I'll do two more. Sorry, I wanted to show a graph as well. So I'll do two more, but let me show you one more table at least. One more table and then we'll do a graph. Okay. See another XY chart here. So the x values here, negative 3, negative 2, 0, and 1. Y values here are, that's 4, it's supposed to be a 5. Okay. And then a 4 and then a 6 there. Is this relation a function? Is this relation here a function? Is every x paired with one y?
No.
I know, it's like, we had two options, right? Classic math teacher gives you two examples, one that's a yes, one that's a no, but now you throw out that third one, it's like, well, now I don't know which one it is. So Tyler, you want to say? Go ahead, what do you say?
I think it is a function.
You think it is a function, okay?
Because there are no repeating x values, but only repeating y values.
Okay, yeah, and that's basically it. Yes, I mean, that's one way to think about it. Yes, right? That kind of throws us off here. Wait a minute, this y value shows up twice. But a function is where every x is paired with one y. Is this x only paired with a 1y? Do you see another -3, as Tyler said? Right, there's another -3, so -3 is only paired with 4. -2 is only paired with 5. 0 is only paired with 4, and 1 is only paired with 6. So yes, Tyler's right. This is a function. And that is kind of a key thing there that Tyler maybe identified for us. When you see repeating x values that go to different y values, so here x is -4, x is -4, they go to different y values, that indicates not a function. But this right here is okay. All right, let me show you one more here. And this I'm just going to graph. Okay, so in red there, right? Is this a function? See Tyler shaking his head no. There's no numbers. Paige is also shaking her head no. There's no numbers here though. How are you supposed to tell? Michael's shaking his head no, which is making fun of Paige. How are you supposed to tell here? There's no numbers. So Tyler, you want to say something?
The vertical line test.
Ah, right. There's the vertical line test. That may be the first way you guys ever learned about how to determine something was a function or not. Okay? So yeah. Can you kind of like describe what is a vertical line test? How do you use it here in this case of like this graph?
Draw a vertical line. Which is like the y-axis.
Okay.
Over the
So like draw a vertical line like right here, you're saying. And what about this vertical line indicates that we don't have a function here?
Touches the line twice.
Yeah, so we're hitting our graph at 2 points. Okay, so yeah, not a function. Okay, it's relation, not a function. Okay, and think about what it means, right? Think about what it means to have a vertical line hit our graph in 2 points, right? Go back to this function here, or this relation here that was not a function, right? Why did it fail? We had one x value, -4, right? This one x value, -4. It had two different y values. Well, look over here. This vertical line, it has some x value, right? Whatever this x value is, it crosses the x-axis, right? That x value is paired with this y value, right? But this x value also is paired with this y value, right? Because you have 2 points on your graph. So this one x coordinate goes to two different y coordinates. And that's why that vertical line test works. Okay, allows us to determine it's not a function. Okay? Question anything? All right. So, we talked about functions, kind of beat that horse to death. Let's continue on then to talk about inverses. All right, so an inverse, okay, it reverses the pairings of a relation. Reverses the pairings of a relation. Okay, so for example, if f is -4, -2, 0, -3, 1, 2, and 4, 1, okay, F inverse, which I'll show you that, F inverse is shown like this. It's F with like a to the -1 power. So F to the -1 like that. What would the inverse be then here? Well, if F was -4, -2, what's the reverse of that? Those would be that would be the opposites, right? Opposites. Negative becomes positive, negative become positive. I'm saying reverse them. So -4 and -2 would become instead, what's the reverse of that order? -2, -4. So we flip the order around. That is reversing. Okay? And so then Luke will be the next point there.
-3, 0.
Yeah, you got it exactly right. Just flip them around, right? And then 2, 1. And then 1, 4. Okay? So there's the inverse relationship. Okay. There are times when a function, if you take the inverse of a function, the function's inverse will not be a function, right? So sometimes the inverse of a function will be a function, sometimes the inverse of a function will not be a function, okay? We're not going to worry about that too much right now. We'll worry more about that bridge when we'll cross that bridge when we get to it later in like square roots and stuff like that. Okay. So question. Can you hang on just for this one thing, and then you can go. Yeah, I mean, I just want to make sure you don't miss this here real quick. Okay, so the other thing we need to be able to do here is to find the inverse of a function like rule. Whoops. And I'll do like a line here to start out. Again, we'll get more advanced. Sorry, that's circle right there. Okay. So our directions here: find the inverse of f of x equals 3x plus 2. Right? How are we supposed to reverse this? Like when it's points, it's pretty obvious, right? You just reverse the pairing, right? -4, -2 becomes -2, -4. 0, -3 becomes -3, 0. But we got to reverse this. How are we going to do it? Well, let me show you. Okay? So here are the directions we're going to do. So we're going to make it y equals 3x plus 2. So I'll write over here. So we're going to replace f of x with y. So you see there, I had f of x equals 3x plus 2, and I just make it y equals 3x plus 2. It's in slope-intercept form. Yep, exactly right. It's a line, okay? But we're going to find the inverse of this line. So the next thing we'll do, you guys maybe remember doing, does anyone remember kind of doing this kind of thing before, finding the inverse of a function? Yeah? You remember what the next step is? We're supposed to do something with y and x.
Why are you supposed to move it?
So we swap them. So we swap.
So it would be x is equal to 3y
Exactly.
plus 2.
Swap y and x. Anywhere you see a y, put an x. Anywhere you see an x, put a y. Which is exactly what we did up here, right? Isn't that what we did? We swapped the y's and x's. We swapped them, right, to get those points. That's what we're going to do here with the function. Make it x equals 3y plus 2. And then we're going to solve for y. Okay? So this technically, once you swap the x's and y's, this is the inverse. In some sense, we're done. But typically, when we write a function, we have it solved for y, and then x is on the other side of all the numbers. So right now, it's kind of backwards, right? We have the x that we solve for. We've solved for it in terms of y. We want to get the y by itself and have it in terms of x. So we need to start getting this y by itself here. So what's with the y that we need to get rid of? The 3 and
the plus 2.
The plus 2. Which one should we get rid of first?
The 2 plus 2.
Yeah, subtract 2 on both sides. So I'll put like a -2, -2. Okay? So those will cancel. And x minus 2, are those like terms?
No.
No.
It's just x minus 2.
So it's just x minus 2, exactly right. Equals, what's going to be left over here on the right-hand side? 3y. Okay? What do we now need to do to get the y by itself here? Divide everything by 3. Okay? Remember what you do to one side, right? You do to the other side. And each individual term there gets divided by 3. So that's going to cancel. I'll have y equals there. And let's see here.
1 divided.
Yeah, there's a 1 in front of that x. So you can make it 1/3 x if you want, and then minus 2/3, right? Because that fraction doesn't really simplify. Okay? And the last step here is replace y
With that.
with f inverse of x. Bless you. Okay? Replace y with f inverse of x. Remember, we started with it f of x equals. We're going to put it back in that form. So f inverse of x equals 1/3x minus 2/3. Okay? And there it is. Okay. Avery, if you're good, you can. Thanks for waiting. I just wanted you to see that. All right. So I'm going to give you guys a chance to try one on your own here. Okay. And I have one more little thing to show you, and I think we should really get going. Okay. So let's see. Can I fit this all on? Okay, so I'll leave that example up there so you can use that to kind of help you. Okay. And then I want you guys to try. Find the inverse of y equal, I'll do it this way. Find the inverse of f of x equals 2x plus 4. Okay, so you guys try this one right down here, and I'll leave that other example up there for you to see. Take a minute there. Go ahead and give that a try.
Can you check my 1%?
Yep, I'll come over one second.
Try to replace the, I accidentally wrote extra this one, but so I did the minus 4 minus 4 minus 4.
Then do everything by 2? So don't forget to swap the x's and the y's.
So in the end it should be x.
And then f inverse 1 half equals 1 half x.
Is that what that is?
It's a -1. It's like, may I see your
Yeah.
So it's going to look something like this.
I couldn't tell from up there. I don't know what it looks like.
So f -1 x like that. Okay. So you're squeezing in there.
I just didn't know what it looked like.
Thank you. Yeah, that's the idea. Okay. Yeah. Okay. Luke, can she get through there real quick? Thank you. So don't forget that you swapped your x's and your y's. I'm sorry. Boo. Swap your x's and your y's. So you want to put an x there. For those plain cheeses or those burnt ones? I was going to say extra toasty. Sorry, right? They've never been burnt.
Yeah, never.
Yeah. No, I love them. Cheese is delicious. Okay. So what's 4 divided by 2? 2 divided by 4 is 1 half. 4 divided by 2. Which just applies to what? What's 4 over 2? Last 2 different. And then that's pretty much it. The only thing you should really do is make that f inverse of x, like the little f to -1 like that, and put it back here. Looks good. Okay. Good job. Yeah, go ahead. Yeah, looks good. I like the good notation there too. Okay, looking good. Good job. Yeah. Got it okay. Yeah. Yeah, good job. Right here? Yeah, good job. Got it okay? Is this right here? Good job. Well done. I thought I already saw yours. I was like, yeah. Oh, wonderful. I'll check you out. Okay, that looks good. We can talk about that one if you want to in a little bit, and then the even odd meter looks good though too. So I'll give you credit. Let me yeah.
Did you mark me down for getting?
Yes, I got you, Bob. Okay. Here is the answer. Okay, there it goes. All right, 1/2 x minus 2. Don't get the f inverse of x there. Okay. I'm going to show you one more little thing. Okay. But then I'll get you guys started on your assignment. Okay. And what I want to show you is how to verify, how to prove that two things are inverses of each other. So let me furthermore say, show they are inverses. Okay, so here's like a second direction right here. So here's number 1, find the inverse of that. Number 2, show that they are inverses. Okay, so remember I said the idea of an inverse and a function, okay, is that a function should be canceled out by its inverse, like completely undone. Okay, so what do I mean by that? I'm going to take my inverse function and plug my original function into the inverse function. Okay, so I'm going to take my original function here, f of x, which is the 2x plus 4. I'm going to plug it into this function. Okay, I'm going to plug it in for x. So this is what it's going to look like. Okay, and I'll try and do the layers here. So I'll do the f inverse layer in blue, and I'll do the f in red, so you can kind of maybe see it more easily here. Okay, so f inverse in blue, so 1/2, and then parentheses, and I'm plugging f of x into f inverse. You can see right there I have an x in my f inverse, so I'm going to put that 2x plus 4 in there. Okay, and then minus 2. So in blue is the f inverse, in red, right, is the f. Okay, and now we have some simplification that we can do. What should I do with this 1/2 in front of the parentheses? Distribute it, yeah. So 1/2 times 2, 1x. 1/2 times 4, 2. And then I have this minus 2 I got to bring down. And then what can I combine together here? 2 and the minus 2, they cancel out. And so I'm left with just plain old x. Okay? Did the inverse undo my function here? I got just x. So the answer is yes, this is good. But we're not done yet. Because I also have to do it this way. I also have to plug the inverse into the function. Okay? So again, I'll keep the inverse in blue. I'll make the function in red here. Okay, so you can see this. Very patriotic. All right. So in this case, my function, which is 2x plus 4, so 2 parentheses, I'm going to plug the inverse in for the x here, so 1/2 x minus 2, okay, and then the plus 4 there. Okay? So you see the difference here. In the first one, I plugged the function into the inverse. So this went into the x that was here. In the second one, I'm taking the inverse, right, inverse, and plugging it into the x there. But, excuse me, let me do the same thing, right? Distribute. What's 2 times 1/2? What's half of 2? 1, so it's just going to be 1x, right? What's 2 times minus 2? Yeah, negative 4, and then I have that plus 4 right there. What's negative 4 plus 4?
0.
So it's 0. They're going to cancel, right? I'm left with just plain old x. Okay? That is how we show that we got the right inverse. Okay? If you plug the function into the inverse and you get x, and if you plug the inverse into the function you get just x, then you know that they are inverses. Okay? Since we got x in both situations, these functions are inverses. Okay. So that's how we're going to show two things are inverses or not. All right.